So in this question, you need to create the shape class, the class called shape, and the shape class is going to be the parent. And the circle, you need to then create the class circle and the class square, which will inherit from shape. So this is a relationship where circle is a shape and the square is a shape. Now there will be only one method in the shape class. So in the shape class, you'll have the draw method. You will need to then overload the draw method in the circle and the square. Whenever you hear the term overloading, you have the same function name but different implementation, different functionality within the function. And then we need a virtual function. A virtual function is only present in a base class. So in this case, it will be present in the shape. The reason why we have now the virtual function is a function which will be overwritten inside the children classes. And so the virtual function is in the base class, and the virtual function will be overwritten by the child classes. And the reason why we have a virtual function is such that we have one single array. And here, as they say, don't use different arrays. To have this clearer image, imagine you have this array where you have 10 elements, 10 integers. You can only store integers, but you cannot store doubles in this array. Now let's say you have an array of doubles. You cannot store integers. The only type you can store inside this array is of type double. What if you have a shape? Now in this shape you can store objects of type shape, and you can store objects of circle and square, because a circle is a square and a circle is a shape and square is a shape. Circle is of type shape and square is of type shape. Therefore you can store circle and square in this array because it is of type shape. Remember that a virtual function can be only used with a pointer to the base class. If you don't have a pointer to the base class, then it is not possible to use a shape. And so when they tell you to use virtual function, always start by having a pointer to the base class in an array. So we take this array and we put it inside. This is the output, this is the driver. You need to have two objects, one for circle, one for square. So we start by creating the class shape. So the class shape will have one method that is public, because if it was private, then all classes which will inherit from shape will be unable to access all the function, or every class which will inherit from shape cannot have the private attributes. All private attributes to shape cannot be inherited. So we have the public. And so within the public, we need one virtual method. That is the virtual method. Now this is the virtual function. It will have return type of void, and it will be called drawing. I believe it is one draw function. It is called draw, and it is virtual. You can make this as an abstract class by putting 0. This 0 will indicate that this is an abstract class. Or you can just stick to the normal convention that this is a shape class, parent class, not an abstract class. You have the draw, so you have the draw here, virtual. Let's see out drawing shape. And we have not specified any shape because this is just the shape class. Now we have another class called circle, and circle will have public inheritance from shape. We don't want private inheritance because the methods methods we want to inherit or override should be in the public. So if it is public, then we inherit publicly. So this will be public, and we're going to be overwriting the draw method. I repeat, a virtual function is just found in a derived class. This is void drawing a circle. Now we have another one. This is inheriting from shape, and this is called square. The square, so drawing a square. Let's stick to the exact command. I draw a square or a shape. I draw a shape. Here I draw a circle. And here I draw a square. Now we can have this, we can have this array. This array will have a size of 2 because they want 2 objects. Object 1 will be of type circle, C1, and then the square will be SQ1. This is here an object. Now let's put inside the array, because the array is a pointer to the shape. Inside, let's use now let's create a variable where this variable, to explain the picture, this is a pointer to an object of type shape. This will be called, I'll call this a pointer. Shape pointer will be equal to the C1. Now based on this pointer, I would dereference the pointer. After dereferencing the pointer, I would call the draw method of the shape. and there is no need for creating the array now. If we call the drove method on this pointer, there is an alternative convention. Instead of this, you can have the arrow. They're the same. There is no difference. So if we run this, we can put the semicolons. Square, square. So it is all semicolon problems. Here I am drawing a circle. Now because this pointer is pointing towards circle, so it will print the overwritten function. This is dynamic binding. So what is the object type? The object type is of type circle. We are using a pointer of the base class. Now if you don't use virtual, what will happen? This will be the output. I draw a shape. That is if you don't use virtual. Now if you don't use the term virtual, this is static binding. But if you keep the virtual, you can see that we are drawing a circle. Now the same concept, the same as this, but we'll use an array. Whatever we've done in here, we can then put inside an array. The array will be every single object in the array will be of type, will be a pointer to the shape. Then say that at array 0, I'll be putting C1, and then at array 1, I'll be putting SQ1. Now we need a for loop for int I is equal to 0, I is less than 2, I plus plus. We can then access the array because each element in the array is just here a pointer to shape. We can dereference the pointer, and after dereferencing the pointer, we can call the draw method. And this is here a clear. This is all polymorphism. When you have the same method, the same interface, the same method name called on different objects, this is polymorphism. And so now, instead of this notation, we can have the arrow. And then we can, as you can see here on the output,